In your crypto mining journeys, you'll often find a time where you need to run new wallets, and a lot of people will advocate to run those in VMs. And today I'm going to show you kind of an alternative where you can isolate those using containers, spin those up extremely fast, very minimal resources, and this is essentially going to replace your need for having to spin up entire virtual machines just for storing your wallets and kind of keeping them separated from a system perspective. So I'm over on Mining Pool Stats right now, and I'm on the new coin list. So these are the recently released coins. And we can see like this Blobfish was released 10 days ago on Kapow. We've got another Kapow coin. We've got a SHA-256 coin, Neoscript, a bunch of new coins here. And you really don't want to just go and install these wallets on a primary system or anything like that. It's always recommended to install these in an isolated environment. And you want to, in an ideal scenario, you would install each wallet in its own isolated environment. And thinking about that, you might think to yourself, that's a lot of hardware that I would need in order to do that. Well, I'm going to show you a way today where you can actually do this with very minimal hardware. In fact, I am doing this with a mini PC that has a 4-core, 4-thread processor and 16 gigs of RAM. So a very minimal spec. In fact, I think that mini PC is around like $120. This does not require a lot of hardware. So over here, you can kind of see that system I'm working with. So it's got an N100 in it. I am running HiveOS on this. This is my home lab server. I run it in HiveOS just because it's a little bit easier for me to manage. We've got 512 gig NVMe in it. And this is what we're going to be running on it today. Now, you've got a couple options. In the world of Docker, you can either spin up a Docker container that basically has a web portal to it that allows you to basically connect to the system, use the GUI, and everything's kind of great. The other option you have is called Chasm, and that is essentially workspaces within Docker. It is its own platform, and it's got some caveats to it, but you can kind of see this is actually Chasm here. And you can see I can open up Chrome. We can go ahead and just say launch here. And this is running in its own isolated container. You can see it's relatively snappy. And it's running a full version of Ubuntu. The first option I mentioned, we're also running a full version of Ubuntu. Also very snappy. We've got our internet browsers. We've got our terminals. We've got everything we need to be able to run wallets in these. And so today I'm going to show you how to set up the Docker instance that you would be able to connect to. We're not really going to cover Chasm, the workspace side of things, in this video. I may cover that in a different video. In my opinion, while it's more feature rich, it's not necessarily the best option for spinning up wallet containers because it can do profile saving where it can persist the data, but what you would end up with is you would end up with a scenario where you had to create a username and password login for the Chasm dashboard for each coin you wanted to run a separate wallet for. So not an ideal situation. It's still doable, but today I'm going to show you basically how to do everything native in Docker. You don't really need any third-party apps, anything like that. And this is going to be basically a one command to get it up and running. It's going to basically give you anything that you would need to do in Ubuntu, you will be able to do. So we're going to hop on over to our HiveOS session. And if I run a docker ps-a, these are all the containers I'm currently running. You can see I've got that Ubuntu VM, and that's what we're connected to here. We're going to spin up a new one. Now, what I like to do is I like to create a data folder for, the blockchain data, anything like that. So to do that, we're going to do mkdir. I've got data, and I'm just going to call this walletvms. All right, now within this, we're going to basically just run a docker run command. So this is assuming you already have Docker installed, but we're going to do a docker run. We're going to run this detached. We're going to give it a name. For the purposes today, would go ahead and let's just set up Zealous. So I'll just name this wallet_zel. And then we're going to do restart. Normally I do a restart always, but for these containers, I do restart unless stopped. So if I stop the container, then I don't want it to auto restart. And this is because really I'm only going to start this container up when I need to access the wallet. Any other time, the container is going to be stopped, the wallet's going to be offline, and that is kind of what we're working with here. Next up, we're going to do a port mapping here. So I'm going to do port 6081. That's going to be anything you want, but that's going to need to map to port 80. The container does run everything, all the UI on port 80. Now we're going to do a volume mapping. I'm going to do /v, and we're going to use that path we just created. So /data /walletvms. We're going to add another slash. We're going to have this create a subfolder for the coin. So we'll do Zel here, and then we'll do colon, and we're going to just map that to /root. What this is going to do is any apps we install on our desktop, anything we write to our profile, the app data folders, the wallets create, it's all going to store it on our host server in this folder. So essentially what we'll end up with is this walletvms folder that will have all of our wallet.dat files in it that we'll be able to set up like backup jobs, anything like that. We don't have to worry about setting backup jobs within those VMs or those containers. We can just set it up on the host machine itself. But because they're going to be running in containers, they are isolated. So one wallet can't see the other wallets. And then we want to make sure that we also map the shared memory path. So we're going to /dev/shm. We're going to map that to the same thing on the container. And then the container image is actually going to be tiryoh/ubuntu-desktop-lxde. That's going to be the GUI it's running, and VNC, because this is running no VNC as a front end. So we're going to go ahead and run this. This is going to spin up a container. If we do a docker ps-a now, we can see we've got our wallet Zel. We've got it listening on port 6081. So now if I hop over and we go to the IP address of our host, :6081 in a browser, there you can see that our container /VM is already up and running. And so we can pop open, if we pop open a terminal, so we get system tools, LX terminal, we can do an LS. We can see we just have a desktop folder. If we hop back on over to our host, if we do ls on data /walletvms/Zel, we can see we have that desktop folder here as well. And we also have the .config, .cache, .dbus. So now that we're on this system, I'm going to hop over here to the Zealous release page, and we're going to download the GenesX wallet for Linux. So I'm just going to right click on this, do copy link address, and then we're going to hop back over to our session. You can't direct paste here, but if you hit this little arrow to the side, you can bring up the clipboard, you can paste it in here, and then recopy out of it, and then you can paste it here. So we're going to do a wget on that. That's going to go ahead and download the file, and then we can, if we can run an unzip on that if we want. Let me go ahead and pull up the File Explorer. So we can see it's here. We can go ahead and we can do an extract here. That's going to extract the files. So now we've got our wallet. What I'm going to do with this wallet, we can collapse this by hitting that arrow. Because this wallet has a couple different files, it's not just a Qt wallet. I'm going to do create new folder. And then we're going to just name this Zealous. And within this, I'm going to put that file, that folder, and that folder. We can go ahead and delete the zip file. We don't need that anymore. And we can move the Zealous folder to the desktop, which we already did. Just got to give that a refresh here. Oh, we actually create, there we go. Okay. I believe did we create a shortcut there? I think yep, we did. Let's go ahead and delete that. Accidentally created a shortcut instead of moving it in there. So let's do a cut. Let's get rid of that shortcut. And let's do a paste. There we go. So now our wallet is actually on the desktop here. And this should be persisted. So if we go back to the host and we do a ls on that folder again, and we do ls on desktop, you can see we now can see that Zealous folder. So let's hop back on over. We can close this window. Open Zealous. Now we can open the app. It's going to tell us it's an executable. Just hit execute. And it's going to launch the wallet. Now we can walk through the process of creating a new wallet. I'm just going to do this real quick. We're just going to name this primary. Give it a password. Hit create. And this is going to be generating the T1 points. So while that is running, if we hop back on over and we do search again, we can see that we've got a few more folders now. So we've got this .local. That has our share, and then that has the Gen6 folder in it. That has those temp files that are being created. So everything is kind of a mapping over to this container right now. And what this means is at any point we could actually delete the container completely and rerun it, and it will still have all these files as long as we give it the same folder mapping. So I'll fast forward through this video. We will let this create and get in the wallet. The data table is generated. It's going to give us our seed phrase. Go ahead and copy that, save it wherever, and just hit that we saved it. And now we can see that we're in the wallet. So if we go ahead and close out of it now, let's go ahead and try to open it again. Just make sure that we can log into it. Our password, hit next. Okay, we can see we are in. So now what we're going to do is I'm going to go ahead and hop on over here. And we're just going to do a docker stop wallet _zo. That's going to go ahead and stop it. Now, if we give this you can see it auto disconnected us because that container is no longer running. If you try to connect, there won't be anything for it to connect to. So now what we want to do is we want to, before we start it, let's just verify that all the files are still there. So we're going to do walletvms zil. And you can see we now have this wallets folder too. So if we go into this, we've got a mainnet folder. And then within this, we have that primary. That is the wallet that we created. And this is basically our wallet file. And in fact, if we do a nano on that wallet address, we can even see our public wallet address that we could send funds to. All right, so that is up and running now. So now the container stopped. If we, at any point, we could restart this. So if we do a docker ps-a, all right, so right now our wallet and our whole node, you know, this isn't really running its own full node. It's not like a Qt wallet, but this wallet itself is currently offline. So we're kind of sitting, it's completely cold, it's isolated, it's not connectable. anything like that. If we want to start it, we just do docker start wallet_zil. Let that start up. If we hop back on over, give this a refresh. And you can see it's up and running already. We've got our Zealous folder and we've got our wallet. Let's go ahead and make sure we can log in. Next. And there we have it. So the data is being persisted. Everything's there. In the event we wanted to take a backup, all that we would have to do is back up our /data/walletvms/zil. This contains everything in it that we map to the container. So in the future, if we wanted to run this container on a different system, we could just copy this folder to the other system and it would start using it. This has all the information in it. It's got the wallet files. It has everything that we would need in order to restore that on any other host or anything really running Docker, which is the beauty of this is, we're not running a shared environment, which you could certainly do. If you wanted to run 10 wallets on this, you could do it. You can run as many as you want. It is sharing resources with the host. Another cool thing about this is you don't have to pre-allocate resources like you would to a VM. So you're able to run this on a Docker host, and whatever resources are available, it will try to consume those. And you can turn it off when you're not using it. And it's really not, you don't have to allocate, any additional disk files, anything like that. Everything is running on the host itself. So this is a great way to get it up and running. And if we go back, you can see I actually have an Ubuntu VM. This is just the system that if I'm doing anything in Ubuntu, I can just use it. So if we hop to 6080, this is another container I'm running. So it's using the same image, but it's a different container instance. And so that means all the data files are independent of each other. They don't cross over. So you notice you don't see the Zil file here. And so this is its own isolated environment. And I can do, anything I wanted within this environment. So if I wanted to, install Visual Studio, do some development, I could do that. If I wanted to run this as just like an app server and, debug or test any apps, I could do that. I could really do anything I want on this. I think we do have Google Chrome installed, so we can do --no sandbox. So if we do this will actually launch Google Chrome. And it will prompt us saying that it couldn't update to the latest version just because it is an older version. So we're going to go ahead and say reinstall and hit download Chrome. Except this is actually going to download the latest version of Chrome. And we're going to go ahead and install that. Say I. And we're going to say enter. So it is done installing. So if we close out of Chrome and we relaunch that, there we can see we are now on the latest version of Google Chrome. So now we can go to mining pool stats if we wanted to. So we are in a full functioning environment. And what I really like about this is all it requires is just a web browser tab. You don't need any type of client application, anything like that. It's using no VNC, so it's as if you're sitting in front of the computer. If it was a real computer, this is actually running in layers on Docker. So as you can see, this can be very flexible with being, wanting to run anything you want that you want to run in Linux. You could certainly run that on this system. And the image that we're working with, it does have some out of the box things. So we've got, if we go to applications, we can kind of see that we've got, obviously, Chrome is installed, Deluge, which is like a torrent app, and a file transfer app. That's also installed out of the box. So if you wanted to transfer any files or anything like that, you could do that. And then obviously calculator. It's a really trimmed down version of Ubuntu, so it's not running much at all, but you're able to install anything you want. So you can always pull up the LX terminal, and through here you can run your apt install commands. So we can run an apt update if we want. This will go ahead and update the packages. But you have a full working Linux environment that you can do, anything you want with. And, this is also a great way that if you need to run a specific version of Ubuntu for a wallet, like some of the older coins that I still work with, they're very old coins from, back, 2016 timeframe, and they will only run on Ubuntu 18.04. They don't run on 20 or 22 or 24. So for those, I have to run an older version. I'm able to do that through this process as well. So it's a really simple way with a single command. Again, the only command you have to run to get that up and running, once you create that folder, is, if we get back up there, you're just going to do this docker run. And really, you're just doing the port mapping, mapping the folder, mapping the shared memory drive, and running the container. And that's all there is to it. Like I said, this is kind of that quick and easy way to do it. Chasm gives you some more things that you can do. If we just hop into this, you can see the UI is obviously a lot cleaner. It's got a lot more apps installed, but everything that you can do here, technically you can do in the other way as well. This one gives you more of a robust dashboard. I will cover workspaces in a different video. I don't want to get into that today. Just wanted to give you guys a quick rundown of what you could do to get those wallets installed through containers. And, you could spin up as many of these as you want. The only thing, just make sure you use a different port number here. So if we were going to do clor as an example, we would just do wallet_clor, run that on port 6082. We would map that to a clor folder. And go ahead and run that. If we do a docker ps-a, you can see we now have 3 of those VMs running. They're all running the same Docker image, but they're 3 different instances, and they have different folder mappings and different ports behind those. So now if we go to port 6082, you can see we are now in that fresh VM that doesn't have anything in it. If we hop back on over to 6080, you'll see everything that we just had open is still opened. So as I mentioned, this is like you sitting in front of the system. So if you don't close anything out, next time you go to that web URL, it's still going to have everything up for you. It's not doing like a remote desktop session. It's doing a pure VNC session connection. So it's always going to kind of be where you left it until you do a stop. Once you do a stop and a start, it's like doing a shutdown and a reboot where it'll give you a fresh desktop. But so if you ever close out of this tab, so if we close this tab and we had stuff up and we were like, oh, I forgot that I wanted something there, you can always pop that back open and still has everything open that you had there before.